Here we're going to learn how to utilize our stoichiometry skills that we've learned so far this year and apply them to gas laws. Now, so far this year in our stoichiometry practice, we've converted between grams and moles of two different substances in a reaction. Maybe starting with a certain number of grams of one substance and ask how many grams of another substance we're going to produce. Now that we've been looking at gas laws and we've been looking at volume in terms of liters, we're going to be able to convert between grams and liters now, and not just grams to grams of something else. The only new conversion that we have is our 22.4 liters per mole conversion, as long as we're under conditions of STP. And those are what we're going to be concentrating on as far as learning gas stoichiometry. So let's look at this problem that you have. We want to produce 9 liters of oxygen under conditions of standard temperature and pressure. And we're going to do that by decomposing potassium chlorate, KClO3. So we want to know how many grams of KClO3 we're going to have to decompose in order to produce 9 liters of oxygen. So the first thing that we need to write down is a complete balanced chemical equation for this reaction. So we know that potassium chlorate is going to decompose into potassium chloride and oxygen. And then we need to balance it. Now remember, these coefficients here, this 2 and this 2 and this 3, they represent our mole ratio. They represent that for every 2 moles of potassium chlorate that is decomposed, we're going to produce 3 moles of oxygen. And then under the equation, we want to write what we're given and what we're trying to find, just to give us a little visual. So we know we're given 9 liters of oxygen. That's what we need to produce, 9 liters of oxygen. And we want to determine how many grams of potassium chlorate we need to decompose in order to produce that 9 liters. Now, in order to get from liters of oxygen to grams of potassium chlorate, we need to convert to moles of oxygen. Then we can use the mole ratio from the coefficients to get the moles of potassium chlorate. So here's how we're going to lay it out. We're going to start with our 9.00 liters of oxygen, and our first step is going to be to convert those to moles of oxygen. So we're going to put liters of oxygen on the bottom so it can cancel out, and we're going to use our 22.4 liters per mole of oxygen conversion. And how we know it's 22.4 liters per mole is that we're given conditions of standard temperature and pressure. And we've learned that under those conditions, for any gas, for a mole of any gas, you have a volume of 22.4 liters. So we're able to make that conversion, and our liters are going to cancel out. Remember, that's the goal of stoichiometry, get our liters to cancel out into another unit that we can use. Now that we have it in moles of oxygen, we can convert from moles of oxygen to moles of potassium chlorate. And we're going to use the coefficients from the balanced equation. So I'm going to use my 3:2 ratio. 3 moles of oxygen convert to 2 moles of potassium chlorate. And I'm getting those numbers directly from the balanced equation. So as I have it laid out here, my moles of oxygen are going to be able to be canceled out. Now I have my answer in moles of potassium chlorate. Well, of course, once we have it in moles, we know we can convert that to grams of any substance. So I'm going to set up one more conversion factor where I'm going to look at the periodic table, and we're going to add up the molar masses of 1 potassium, 1 chlorine, and 3 oxygen atoms. And when I do that, I'm going to get 122.55 grams per mole. So now I can cancel out my moles of potassium chlorate and convert those to grams. Now we have all our units canceled out. We are left in the units that we want to find, grams of potassium chlorate. So now all we have to do is do the math. And remember, we want to multiply by every number across the top and divide by every number on the bottom. So we're going to take 9 times 2 times 122.55 divided by 22.4 divided by 3, and that's going to be equal to 32.8 grams of potassium chlorate. So if we want to produce 9 liters of oxygen, we need to measure out 32.8 grams of potassium chlorate. Now, the other way that this problem could be set up is if you were given 32.8 grams of potassium chlorate to start with, and then be asked to determine how many liters of oxygen would be produced. But this is a backbone for every stoichiometry problem that you will be asked to do in this chapter.